Okay. Assalamualaikum and salam sejahtera again. Okay. I see you. Okay. In still in chapter 4. Okay. Chapter 4, 1 for part D. Okay. So now we look on the data configuration. Okay. So previously, okay, we are considering on the start configuration. Okay. Right now we see on the data configuration. Okay, for the line current, okay, so the data configuration also have the line currents, the phase currents, and the line voltages and the phase voltages. Okay, so here, okay, the data configuration means, okay, your red phase, your Y phase, and your P phase are connected in data or also called in mesh connection. Okay, so your IR, okay, your IY, IR, IY, and IB is your line currents. Okay, while your phase currents, okay, which here is your IRY, okay, and your IYB, okay, and your IBR, okay, is your phase currents. Okay, and for the data configuration, okay, so your line voltages is equivalent to your phase voltages. Okay, so meet your VRY, okay, your VYB, okay, so and VBR, okay, is your line voltages and also called as your phase voltages. Right, so this is the definition in data connection. In data connection. Okay, please correct this. Okay, so the line current. So this is the data connection load. Okay, so the line current IR, IY, and IB is in green dash box here. While the phase currents is defined in the red dashboards here. Okay, the current through your phases. Okay, for your delta connection, okay, so your line voltages is equivalent to your phase voltages. Your VRY, VYB, and VBR is your line voltages and your phase voltages. Okay, so your V and I in data connected system. So we see the relationship, okay, between the line and the phase voltage in data circuits. Okay, so your IR is your line current, right? Your IRY is your phase current. Okay, since the voltage, the line voltage is equivalent to V phase, so we now considering the KCL for the current. Okay, so the current IRY, okay, your IRY, okay, is equivalent to the KCL. Show that this IRY is equal to IBR plus with the IR, right? Okay, but your IR, we want to see the line current in terms of phase current. Okay, so we group, okay, the line with the line currents and the phase currents with the phase current from this KCL. Okay, so we put the IR line current as the main, okay, quantities that we want to examine. Okay, so your IR from here, okay, from the KCL here is equivalent to IRY minus IBR. Okay, so we know that your IRY is I with 0 degree. Okay, your IYB, okay, IRY, this is your phase voltage, okay. So your RIY is your first voltage, okay, so we consider as a reference, so we put 0 degree. Okay, so for your IYB, okay, is the second phase currents. Okay, so as a reference, so we put as A is differ, your I phase current, your second phase current is differ with your first phase current, okay, by minus 120 degree. So same with the V phase in your star connection. Okay, in delta connection, now we have a difference in current. Okay, so we consider the current. Okay, so the IBR, the second phase current, the third phase current, okay, is I with plus 120 degree. So by considering or by taking all these phase currents, okay, we substitute into your line current here. Okay, so your first line current, your IR is equal to, from the KCL is RIY minus IBR. Okay, so you put the value for IRY and you put the value for IBR. Finally, you will get, okay, square root 3I. Okay, IR is a square root 3I phase. Okay, square root 3I phase with minus 30 degree. Okay, for your IR is square root 3 of the I phase is IRY. Okay, with minus 30 degree in angles. Okay, so your IY is equal to the I phase YB minus I phase RY. Okay, so finally, okay, from the calculation, this give you, okay, your IY is square root 3 I phase IB, okay, with minus 150 degree angles. Okay, so this is when your, okay, IR is equivalent to minus 30 degree. So your okay, is different with your IR, IY is different with your II by 120 degree. Okay, so you will get is about minus 150 degree for your IY. Okay, your IB, okay, from the KCL IBR, okay, you can see here, the IB, where is your IB? IB, okay, is, okay, your IBR, okay, minus with your IYB. Okay, so for your IB, your line current B, okay, is equivalent to, okay, square root 3 IBR with plus 90 degree. So what is, okay, we can say here for the line voltage, okay, for the respective line voltage, IR is equivalent to square root 3 IRY and the angle is theta RY minus 30 degree. For the line current IY, okay, is equivalent to square root 3, okay, phase current IYB, okay, with a theta YB minus 150 degree, and the IB, okay, the line current for IB is equivalent to square root 3 IBR, okay, with angle 30 BR, angle theta BR plus 90 degree. Okay, so the summary for your voltage and current in data connection system, okay, what we can say your I line, okay, is equivalent to square root 3 I phase and the angle is theta phase minus 30 degree. And the I phase is the I line divided by square root 3 and the theta is theta line plus 30 degree. Okay, and the line currents here, okay, the respective line current, your IR is equivalent to square root 3 IRY with the angle theta RY minus 30 degree, and the IY is equivalent to square root 3 IYB with theta, okay, with angle theta YB minus 150 degree. And for your IB line currents, okay, is equivalent to square root 3 IBR with theta BR plus 90 degree. in terms of magnitude, okay, so the magnitude of V line is equivalent to magnitude of V phase. Okay, and the magnitude of I line is equivalent to square root 3 of I phase. Okay, so now, okay, since there are difference, okay, in currents for the data connection, so okay, we see on the phasor diagram of the line current and line voltages. Sorry, the phase currents. Okay, the line current and the phase currents. Okay. So the line currents is defined or is labeled as okay, IR, okay, IR, IY, and IB. The line's current. The phase current is IRY, IYB, and IBBC. Okay. So if we taking the IRY, the first phase current, IRY, as a reference, okay, reference means it contains, okay, the magnitude with 0 degree angle. So from here, okay, from the definition of the I line in terms of I phase, so we know that, okay, your IR is equivalent to square root 3 IRY, okay, and lagging by minus 30 degree with your I phase here. Okay, and also for your IY here, okay, the magnitude is square root 3 larger than your IYB, but lagging by 30 degree with your IYB. IYB is your phase current here. Okay, and then for your IB lines, okay, so you have a larger currents by square root 3 of your IBC and you, okay, lagging by 30 degree with your IBC or your phase angle current IBC here. Okay, so between the phases currents, okay, IRY, IYB, and IBC, okay, there are, okay, differ about, okay, 120 degree in angle, but remaining the same magnitude and having the same magnitude. Okay, they are having 120 different each other. The same also for your line currents. Okay, IB, IR, and IR, IB, and IY. Okay, they also, okay, sharing the same magnitude, but different by 120 degree each other. Okay, so that is how you verify your answer. Okay.